Hey everybody. Today we're going to start our new unit on inequalities, and we're going to start with graphing inequalities. I think this is going to work best if we just take it example by example. Let's start with our first example here. It says a is greater than 2, right? So when we're thinking about equations, right, let's say if it was a equals 2, we would think about this, right? We just know a is 2, right? There's only one value for a. But when we have a is greater than 2, it actually means a can be a lot of different numbers, right? A could be 3, a could be 4, a could be 216, right? A could also be 4.6, could be 2.00001, right? Because that's still greater than 2. So what we want to do when we have something like this, a is greater than 2, with a lot of different values, it would take us way too long to list all those values out, right? I could go on listing these forever. I would never have enough time to do it. But we can show all of the values using a graph on a number line. So I can draw a number line here. Now I don't need a lot of values, but let's put a few on. We'll have 0. I always like to have 0 on my number line. All right, let's put 1, 2. We can put our negatives over here as well, -1 and -2. Try to keep them evenly spaced. That could be better. And now we're going to graph our values. Now, we know that all the numbers to the right of 2 are going to be greater than 2. I'll put a 3 right there. So if I want to show those numbers, right, I can shade in all these numbers to the right of 2. But remember, 2 isn't a value. So we got to find a way to show that all of the numbers to the right of 2 make this statement true, that a is greater than 2. So what we do is we put a circle on 2, but we leave it open because we're showing that the graph of our numbers starts at 2 and goes to the right, but it doesn't include 2, okay? And then we draw a big arrow here to show that this shaded section is going to continue to the right, and all of the shaded areas are our values, right? All of the shaded areas are the values that are greater than 2. Okay, let's look at our second example here. B is less than or equal to 5. Remember, that's what that means. B is less than or equal to 5. So B, if it's less than 5, could be -7, could be -5.02, right? -48. But could also be -5, because B could be less than 5 less than -5 or equal to -5. So if we're going to graph this one, I'm going to draw another number line here. Okay. I'm going to leave a little more room to my left here, so I'm going to put 0 over here. We got 1, 2, 3, 4, 5, and we'll go all the way to -6. It's -1. I'm just going to label my odd numbers to save some room. So we got -1, -3, -5. Now, to graph this, right, we know our graph is going to start at -5, and it's going to go to the left, all of the numbers that are less than -5, right? But because B could also be equal to -5, we're going to shade this in also, okay? The shaded regions always represent the answers. Let's do a couple more. For my first example, I have x is less than 9, right? So we know x could be 8, x could be 8.9, any of those numbers that are less than 9. So if we're going to draw our number line, I want to put +9 on here. I'm going to put a 0 over here. And to save some time and space, I'm just going to count by 3s for this, because I can go 3, 6, 9. So 3, 6, 9, right? That's a lot easier than putting all those little marks to get up to 9. counting by ones. Now, I want x to be less than 9. So I know I'm going to shade in this whole area over here, right? This is all going to get shaded in. And it's going to go all the way right up to 9, but it can't be equal to 9. So that's why we put a circle around it. That's where our graph is starting, but we're leaving it open because x cannot equal 9 for this statement to be true, right? So when we see that open circle, it means that x is greater than or less than, but not equal to. Okay? Now, in our second example here, y is greater than or equal to negative 20. We'll draw our number line again. I'm going to want to have my numbers in the negative range. So I'm going to put 0 over here. And to get to negative 20, let's just count by tens. We'll go negative 10, negative 20, negative 30. So y can be any number greater than negative 20. So let's put our shade, right, is going to go over here, all the numbers that are greater, and y can be equal to negative 20. So since our graph starts here, we put a circle, but we call this a closed circle to show that y can also be equal to 20, right? So when we see this line underneath, when it can be equal to, we have to shade that in. That's what that means, right? Closed circle means equal. If it's an open circle, remember that means not equal to. All right, let's do 2 more and then get out of here. For m is greater than negative 8, right, we'll draw our number line and negative 8. So I'm going to start at 0 over on the right here, and let's count by 4s. We'll do negative 4, negative 8, negative 12. And then we know we're going to start at negative 8, so we'll put a circle there. And this has to be an open circle, remember, just like we had up here, it's always an open circle if it's not equal to, because m can't be equal to 8. We only want to shade in the numbers that are greater than negative 8. And that is going to be all of these numbers here to the right, right? Negative 4 is greater than negative 8. 0 is greater than negative 8. And go ahead, shade those in. And finally, n is less than or equal to 25. Draw our number line. Put my 0 on the left this time. Now to get to 25, count by 5s. We'll go 5, 10, 15, 20, 25. We'll put a 30 on there. And let's just mark the 10s. Okay, so we can clearly see where 25 is. It's between 20 and 30. Now, this is n is less than or equal to 25. So just like up here, because it could be equal to, we're going to put a closed circle on that number, on 25 here. So let's go ahead and put a closed circle on 25, because n could be equal to it, and n could be less. So 20 is an option, 10 is an option, right? All of these numbers that are less. And we'll shade this in, make it nice and visible, so we can tell where our solutions are. Where are the numbers that make this statement true? All right, that's it for today. Just that one topic. Go ahead, finish your notes, submit, and I will see you all in class.